$25,000, right? And let's go ahead and resume our preview. And this is ultimately sort of what we're going to want to fetch from our API. Okay, we want to fetch the price for a particular coin and display it in our view right here, like this. And maybe we can add a comma or something like that. view model up to do that with some dummy data. So here I'm going to go and say at published var coin and at published var price. And they're both going to be blank strings. And I'm going to make a function here, guys, called fetch coin or fetch price. And for now, we're just going to go and say, supply these values with some dummy data. So let's say like self.coin equals Bitcoin, and maybe self.price equals like 30,000, and wrap it in quotes. And let's go ahead and replace this text that we see here with the data that we want to get. Back from our view model. So here we're going to use some string interpolation. I'm just going to delete this and say interpolate viewModel.coin and interpolate viewModel.price. And you guys are going to notice that all we get back is this little colon, right? And that's because, oops, sorry guys, .price. We haven't actually called that fetch price function, right? So there's a couple ways we can do that. We can go back to our view model, and when we initialize this thing, we can just call fetch price, right? And then we can go back to our content view. We can go back to our view model, this little colon, viewModel.coin, and interpolate viewModel.price. And you guys are going to notice that all we get back is this little colon, right? And that's because, oops, sorry guys. Price. We haven't actually called that fetch price function, right? So there's a couple ways we can do that. We can go back to our view model, and when we initialize this thing, we can just call fetch price, right? And then we can go back to our content view, and we'll see that we're getting back the data from our view model that is coming back from that fetch coins function, right? That fetch coins function is just populating these two. Properties with some hard-coded data, Bitcoin and 30,000. So what we're going to do now is go over how we can actually fetch this information from our CoinGecko API. So if you guys remember, I'm going to go and pull up the API documentation once more. We took a look at this simple section, right? And this is how we get the price of a coin. We need to pass in the coin that we want the price for and the currency that we want the price to come back in. In this case, we're looking at Bitcoin and USD. And the API will automatically generate this request URL for us. So if we change those parameters, guys, the request URL will change, and it will give us back the data corresponding to the parameters that exist in this request URL. To see an example of that, let's go ahead and change Bitcoin to Litecoin. And maybe we can do it in euros or something. And you guys will notice that this gives us back Litecoin in euros, right? And you guys notice that these parameters change in the request URL, right? We see the currencies is now euros, and the coin that we want is Litecoin. So if I change it back to Bitcoin and USD and hit execute, my URL request updates and the data that comes back updates as well in correspondence to what this request URL looks like. So we are going to copy and paste this URL, guys, and we're going to go back to our Xcode project and create a URL from that. So we're going to say so we are going to copy and create a URL from that. So we're going to say let URL string, and we're going to paste that guy in there just like that. So even though this is like in HTTP format and this is an actual like represents a URL, in Swift right now, this is only represented as a string. So we need to actually take this URL string and create a URL object from that. So let's go ahead and go over how to do that. We're going to say guard let URL equal URL string from our URL string. And we're going to say else return. So if you guys have some networking experience, this should all be pretty familiar right now, right? We're converting this string here into an actual URL object. And then we are going to now get to the exciting stuff where we actually reach out to this URL and download the data that comes back from it. So in order to do that, guys, we are going to say URL session dot shared dot data task. And you guys are going to notice that we get this option that says with and completion handler, right? So it's going to ask us to pass in a URL request. We already have our URL here. And then it's going to give us something back called a completion handler. So if you guys read the documentation in the autocomplete window, it creates a task that retrieves the contents of a URL based on the specified URL request object and calls a handler upon completion. So we're going to do an in-depth breakdown of what exactly a completion handler is and how it works and all that stuff. For now, I just want us to execute this function and see what happens when we do. So guys, just go ahead and pass in your URL that we created right here. So you guys notice it asks us for a URL request. We can, unfortunately for us here, we can just pass in the URL we just created. But if you guys tried to pass in that URL string, you guys are going to notice we get an error in our compiler, right? It's going to say something weird like this, but basically it's because the data types don't match up. We have to make sure we pass in a physical URL object. And once again, we used this string to create that URL. And then here's the interesting part about completion handler, guys. If you tab over to this and you hit enter, you guys are going to notice it opens up a block of code. And we get access to these 3 parameters. So basically, this is the stuff that's going to come back to us in this completion handler. And once again, guys, don't worry, I'm going to explain that in detail. Let's just go ahead and name these properties: data, response, and error. And let's go ahead and just add a print statement here. So I'm going to say print did receive data. And we're going to do some string interpolation and just pass that data into that print statement. And something that we have to do to make sure this actually executes, guys, is say dot resume. So make sure you don't forget this. This executes, guys, is say print statement. And something that we have to do to make sure this actually executes, guys, is say dot resume. So make sure you don't forget this. This trips developers up all the time. Not sure why Swift makes us do this. It's honestly kind of annoying. But with completion handlers, you do have to call this dot resume guy to actually execute the task. So this data task is going to reach out to that URL and download the data that comes back from it. So let's go ahead and physically run our code on the simulator, guys. This won't work in the preview. I wish print statement worked in the preview, but they don't. And you guys will notice that we are getting this print statement back, right? So we've actually received data from our API at this point, but it's in like a raw data format, okay? We got 25 bytes of data back. So we want to actually transform this data into like a readable string so that we can ultimately update these properties up here and provide our view with that data and have it update once we receive this information. So before we do that, guys, I want us to do a breakdown of what a completion handler actually is and what is happening behind the scenes with this data task function. So I want us to add some print statements here really quickly, and this is going to help us get a better understanding of this. So I'm going to say print, and make sure you add this before the URL session code, fetching price. And then we'll keep this print statement here, did receive data. And then we're going to go after that URL session. And we're going to say print did reach, and make sure you add this better understanding of this. So I'm going to say print, and make sure you add this before the URL session code, fetching price. And then we'll keep this print statement here, did receive data. And then we're going to go after that URL session. And we're going to say print did reach end of function. And I want you guys to pay very close attention to the order that these print statements come back to us in the console. So let's run our code again. And you guys are going to notice that we get fetching price, and then we get did reach end of function, and then we get our did receive data from our completion handler back. So this is pretty mind-blowing, right? even though we wrote this before this guy, so we wrote did receive data before we reach the end of the function, we only get this print statement about receiving the data after we say, hey, we reached the end of the function. So this is the core foundation or essence of how completion handlers work, right? Essentially, guys, this data task, it takes time for us to reach out to the API, retrieve the data, and then get it back onto our device. So the way this code executes is this guy is going to execute, and we see that happening first, and then this URL session data task is going to execute. But this the code that is inside of this completion block isn't going to execute until we get a response back from our server. Let's say that takes 1 second, right? Our code is going to continue its execution. That's why we see did reach end of function before we see that we receive the data back. And whenever that API call completes is when we're going to enter back into this completion block. And get this print statement back. So this is why it's called a completion handler, or oftentimes referred to as a callback, right? It's going to make a call to the API, and then we're going to get a call back statement back when we're going to enter back into this complete. Why we see did reach end of function before we see that we receive the data back. And whenever that API call completes is when we're going to enter back into this completion block and get this print statement back. So this is why it's called a completion handler, or oftentimes referred to as a callback, right? It's going to make a call to the API, and then we're going to get a call back from the API whenever that process completes. But there's no guarantee as to when that's going to happen. We do know it's going to take some time. So this is referred to as our code executing asynchronously or non-sequentially, right? So even though we have this line by line execution, this comes back after we reach the end of the function, because this API call takes time. So I really just wanted to explain that concept to you guys. I think that's a really good stopping point for this video. We successfully reached out to our API and fetched some data, and we have a better understanding of how completion handlers work, guys, and sort of the process that this undergoes. And you know, just another quick note is this is all the stuff we get back from that callback. So we get some data back, we get an HTTP response like, hey, 200 code, you're okay, or we could potentially receive an error. And we're going to go over how to use all of this stuff inside of our completion handler in the next video, before we ultimately start going over how to update these published properties here so that we can update our view with the data that's coming back from our API. So get excited for that, guys. We'll see you in the next one. Peace out. What's going on, guys? Welcome. What's going on, guys? Welcome back. Hope you are doing well. In our last video, we went over how to reach out to this particular API endpoint and actually retrieve some data back from our API. We also went over the concept of a completion handler, how they work, and we noticed some interesting stuff with like the order that these print statement came back in, right? And just to do a quick recap on that, this code is going to execute asynchronously, and asynchronously means non-sequential, right? So we notice that we get this print statement first, this one comes second. Let me add some comments so to just iterate this concept more clearly. And this one comes back third. And that's because reaching out to our API to fetch this data takes time, guys. And we don't know how long that's going to take. And we don't really care, right? We just care that we receive some sort of callback when it's done. And that's what's going to happen when we enter into this block here. So when we enter into this block, we know that we receive some data back. We could potentially receive an error back as well. And we're going to go over how to use all of these properties that we see here. But the main concept that we want to understand here, guys, is that our code continues on with its execution, and we only get this print statement back whenever that process completes of downloading our data from the API. So that's why it goes 1, 2, 3. So that's the concept of a completion handler and a callback. Now what we're going to do in this video is get into how we can actually start parsing that back whenever that process completes of downloading our data from the API. So that's why it goes 1, 2, 3. So that's the concept of a completion handler and a callback. Now what we're going to do in this video is get into how we can actually start parsing this data or transforming it so that we can use the data that we get back to update these properties, and ultimately update our view with data that comes back from the API. So guys, I'm going to pull back up our crypto documentation for the API. And we notice that this is what our response body looks like when we reach out to our API and get that data back. But it's not coming back to us in that format right away. It comes back as raw data. And we have to do some sort of parsing or transformation to get the data to look like this so that we can ultimately use it somehow, right? The name of the coin. And the price of the coin is what we're looking at in particular. We could even use the currency if we want. So this is what's referred to as JavaScript object notation. So this is basically a simple and lightweight data format that's used for storing and exchanging structured information between different programs or systems. So basically, guys, I can just get this JSON data back or JavaScript object notation and parse this information to get the data that I need out of it. So this is a really common format for how things come back in terms of fetching information from an API. So if I'm an iOS developer, I can get data back in this format. If I'm an Android developer or a web developer, I can also receive data in this format and parse it based on the needs of the particular system or client that I'm working with. So we're going to go over how we can start transforming that data into, that JSON format that we want so that we can ultimately read or update these properties we have in our view model here. So Swift gives us something called a JSON serializer that's going to allow us to do this. So we're just going to go ahead and say guard let data equals data else return. So guys, this comes back as optional, right? Because let's say this API call fails, it's not going to give us any data back, right? It's going to give us back an error. And we're going to go over how to handle the error a little bit later on. Right now, we're just going to work with the data. So we're going to make sure that we have this data before we try to use it anywhere, right? And then, guys, we are going to say guard let JSON object equal JSON serialization dot JSON object. And you guys are going to notice here that we just need to pass it some data and it will automatically convert that data into a JSON object for us, right? So here we're just going to pass in the data and we're going to say else return. And guys, we do need to add this try statement in front of it. And we'll go over tries and do's and catches a little bit later. Right now, I just want us to focus on how to parse this JSON data. Okay, so now let's see if we can print out that JSON object. So let's go ahead and say print JSON and print out the JSON object and see what we get back. So let's run our code one more time. And let's see what happens. Okay, so our print statements come back, and you guys check that out. We get that beautiful JSON object back just like that. We see that we have Bitcoin, USD, and our price, right? So while that's a step in the right direction, we still can't really extract any data from this JSON object, right? We don't really have a way of doing that with this raw JSON data. So we need to transform this into a more concrete Swift data type so that we can extract data from it accordingly. So we're going to be utilizing something called a dictionary to do that, guys. And if you guys don't have any familiarity with what a dictionary is, I highly recommend taking the Swift Fundamentals course before proceeding any further with this networking course. But basically, what we're going to do is transform this JSON object into a Swift dictionary type. And a dictionary is just a key value system. And this is exactly what JSON objects are. They're key value structures, right? We just need to cast this JSON object as a dictionary so that we can use it accordingly in Swift. So we're just going to go here, and in the JSON object creation, we're going to cast it as a dictionary that looks like this. It's going to have strings as the keys and any object as a dictionary. They're key value structures, right? We just need to cast this JSON object as a dictionary so that we can use it accordingly in Swift. So we're just going to go here, and in the JSON object creation, we're going to cast it as a dictionary that looks like this. It's going to have strings as the keys and any object as the value. And guys, that's because Bitcoin here is the key. Basically, all of our dictionary keys are going to be strings, and we can have any sort of value associated with the string key. And we'll go over how to parse the value in just a second. Let's just go ahead and run our code again and see what this JSON object looks like now. So you guys are going to notice that it now has brackets, right? So we're actually successfully casting this JSON object as a dictionary now, which is awesome. So the only thing we need to do now is figure out how to cast the values of this dictionary as well. Like, we don't want any of these equal signs here. freelancer. We want a full dictionary object type for all of our JSON data. So we're basically just going to do the same thing we did to cast this dictionary for this guy here. So this is a key and a value. So we just need to break that down one step further, right? So here, guys, we are going to just delete this, and we're going to say let value equal JSON object. And to access the value associated with a key, this is what we're going to do. We're going to go here and say Bitcoin, and we're going to cast this as well. And you guys can say string any, but we can notice that this price is coming back to us in an integer format, so we can just cast this as an integer as well. So now we have a concrete Swift data type with this dictionary to parse our value as well, guys. So let's go ahead here and just say print our value and run our code. And you guys are going to notice now that all of the nasty curly JSON brackets are gone, and that we are getting this all of this data back in to us in dictionary format now, which is incredible. That means we can actually start reading this data from the dictionary to update our published properties up here and give the data back to our view. So guys, we are just hard coding this Bitcoin key coin for fetching our price. We can make this a little bit more dynamic in a second. What I want us to do is just get the data back from this value to update our price. So here we can, for now, just say self.coin equals Bitcoin, and we can say self.price equals this injected value with our string interpolation, and we're going to say value, and the key is going to be our USD right there. So basically, guys, in order to get the value, you need to just say, hey, go into the dictionary and find the key that we want the value for. And in this case, it's USD. And once again, this isn't super dynamic. Like if we were to pass in euros or a different coin, we would want to display different data, and we would have to update this, which we'll do in a second. I just want to see if this stuff is working. Let's also go ahead and just guard let this statement, guys, so our value isn't optional, and return. And let's go ahead and run this code now. And you guys should notice that something really exciting is going to happen. We are going to get back this data here, guys, right? This is looking super, super good. But you guys will notice that we are getting these purple warnings back from our compiler, and it says publishing changes from background threads is not allowed. make sure to publish values from the main thread. And we are going to go over what this means in detail in the next video. I'm going to give you guys a comprehensive breakdown of threading, background threads, the main thread, multi-threading, and all of that stuff with diagrams. But for now, I just want us to fix this problem. And we will go through a breakdown in the next video. So really quickly, guys, just go ahead and Command X to cut those two lines of code. And we're going to say dispatch queue.main.async. And basically, this is going to get us back onto the main thread so that we can update these properties that will ultimately update our user interface. So another thing I want us to fix really quickly, guys, is safely unwrapping this value. So we want to get this price back as a non-optional property. You guys see it's displaying as an ugly optional in our user interface. So to do that, we could just say guard let price equal value USD else return. And then we can just go and inject our price here. And maybe put a $sign in front of it. And let's go ahead and run this. And you guys are going to notice that that looks way better and those purple errors go away. And once again, we'll explain that in the next video, guys. How I want to wrap this up is how we can make this function a little bit more dynamic, just to show you guys how to make your code a little bit more dynamic, just so we're not constantly just fetching the data for Bitcoin. We ideally would want to be able to like fetch data for any coin, right? And this is going to help us figure out how we can pass values into something like a URL string so that we can get dynamic data back in our application. So basically, we don't want to hard code this Bitcoin value, right? We want to be able to pass in any coin to this function and maybe even have the user be able to like search for a coin themselves. So we definitely want to pass in like a coin right here to this function, and then we're going to inject it into this spot right here. So right after the IDs and the equal sign, you guys can delete that and go ahead and make sure that everything else stays in place. Make sure it's ID. And so right after the IDs and the equal sign, you guys can delete that and go ahead and make sure that everything else stays in place. Make sure it's IDs equals, and we're going to inject this coin here. And then make sure this stays the same as well, and VS underscore currencies equals USD. And then guys, up here, we can say, hey, we can now pass in a coin, and maybe we can say Bitcoin, right? And now what we want to do is make sure that we are not hard coding Bitcoin in the other places in our application, right? So basically, guys, when we get this JSON object back, we want it to be for whatever coin we're requesting the data for. So this is going to be coin, and then the coin that we update our UI with is going to be the coin that we pass in here. It does come back as lowercase, so we're going to say coin.uppercase. And if we run our application, everything should look exactly the same. And then what I want us to try to do, guys, is pass in some different data. Maybe we don't want it in all caps. So there's a different way of doing that. We could say coin.capitalized. Yep. So capitalized will just uppercase the first letter of the string. Uppercase will uppercase the entire string. Okay, so let's try it with like Ethereum or something, guys, or Litecoin, and see if it works. And we're going to notice that it doesn't, right? So this is going to help us figure out how to go through some debugging in our code, right? So we notice here, guys, that based on our print statement, we're still getting data back, right? So we are successfully receiving data. So that means we are not getting an error, which is good. We're just doing something wrong in terms of parsing that data. So we are successfully receiving, based on our print statement, we're still getting data back, right? So we are successfully receiving data. So that means we are not getting an error, which is good. We're just doing something wrong in terms of parsing that data, right? So let's see if we can print out the JSON object to see what it looks like, to make sure that we're casting all of this stuff correctly. And we'll see where we went wrong here. So just go ahead and print JSON object, guys. And make sure you do that before the guard statement of the value. And let's run that again. So you guys are going to notice that we get back Litecoin, but it's not an integer type, right? It's actually a double. So here we're trying to cast this value as a string to integer dictionary, but it's this is actually a double value, so that cast is failing, and this return statement hits in our guard, and it doesn't go past this point. So if you guys want to get a more detailed error description in the else statements of your guard, you could say print like failed to parse value. And you could do that for all of the other print sort of guard statements that you have here. You could say maybe like fail to get price, and then you just have to say return. And this will just help you guys, figure out what's going wrong and where in your code, right? So this is sort of just diving into a little bit of error handling and debugging stuff. So now all we need to do is just modify this to a double data type. And you guys notice that if we run our code again, that we're going to get Litecoin back as $64.06. So that looks really, really good, right? Next, guys, let's see if we can do maybe like Ethereum or something and run our code. And you check that out, guys. We're getting Ethereum back, so we're successfully retrieving dynamic data from our API. You guys could maybe do the same thing with the currency if you wanted to get different currencies back, and then you would just replace this guy for the value here. But this gives you guys an idea of how to dynamically fetch data from an API, right? And we're using completion handlers to do that. We're updating our UI with data that's coming back from the API. So this is part of the foundations of what you're going to be doing as an iOS developer in terms of networking, guys. You're going to be reaching out to some sort of API that's going to have some endpoint like this. You're going to get the data back. You're going to parse it, so that you can use it in some sort of readable format with like Swift object types, and then you're going to update your user interface with the data that you get back from that API. So that is one, like I said, one of the core foundations of being an iOS developer. And this is a really good starting point for this networking tutorial that we're going through. In the next one, guys, we're going to talk more about threading, and then we're going to go over how we can handle our responses and our errors here as well, before we get into the more exciting stuff like actually fetching all of these coins from the API and displaying this really beautiful user interface here. So thanks for watching this one, guys. We'll see you in the next one. Peace out. What's going on, guys? Welcome back. In our last video, we went over how to parse the incoming data that we were getting back from this data task into usable formats so that we could extract the data that we need and ultimately update our UI. So that brings me to my next point, where if you guys remember, we were getting these weird purple errors, right? Where it was like, hey, you're trying to update the UI from a background thread. That's not allowed. You have to do that on the main thread. So in order to solve that problem, we did this dispatch queue.main.async, and that got us back on the main thread where we were able to update our UI. So there's a lot to unpack there, and that's what I want to focus on in this video. I want us to talk about the concept of threading in a program, the difference between main threads and background threads, and why this stuff is important and why it all ties together, why it's important for you to know moving forward, and all that stuff. So I have this diagram that I made for you guys to explain the concept of threading in general and the difference between main threads and background threads. So to start this off, guys, what is a thread? So it's essentially just a separate path of execution within a single program. So a thread is responsible for performing some amount of work or doing some task, right? So in our case, we are fetching information from an API to display price data about a cryptocurrency. So that's a task that our program is executing. That task happens on some sort of thread. Now you guys could imagine if our application got more complex and we were fetching information from multiple APIs. About stocks and NFTs and cryptos, and all of those things had separate APIs. Those are processes that all need to execute ideally concurrently, right? We would want those to happen at the same time. all of those processes happen on their own individual threads. So a thread is essentially just a path of execution within a program. So that brings me to my next point. What is the difference between the main thread and the background thread or background threads? And how does that relate to our user interface? So let's start with the main thread, guys. So in any program, the main thread is the primary flow of execution. So this is where the core tasks of the program are carried out. And in an application, like a mobile app, like an iOS app, all of the user interface updates happen on the main thread, because this is the primary path of execution. It gets the most computing power, the most juice, and in order for the user to have a pleasant user experience that involves smooth UI updates, like imagine in our UI here in the completed app, we want this scrolling to happen smoothly. We want like the taps to happen like seamlessly without any lag. You want your user interface to be as smooth as possible, and that's all running on the main thread. So that brings me to background threads, right? So background threads are processes that happened in the background or under the hood, so to speak. And these are separate from the main thread, right? So when you do things like fetch information from an API or perform some computationally intensive task like a complex algorithm and stuff that doesn't really need to be happening on the main thread, you do those on background threads. Why is that? So essentially, guys, if you were to perform some API call that was involved downloading a lot of data, say downloading large images or a large data set, and you did that on the main thread, it would cause your user interface to potentially freeze up and get really laggy because you're performing a complex operation that takes computational power, it takes up memory, it takes up network usage, and you're doing that on the main thread, and you're essentially blocking the user interface from running smoothly and doing what it needs to do. So all of those computationally intensive processes or API calls you want to happen on background threads. So that brings me to my next point, where it's like, what happens when you get information from a background thread and then you need to pass it back to the user interface? So that's what we saw with our code when we went and got the data that we needed, right? But then we tried to modify the user interface by populating these published properties. So when we set these published properties, it published that changes over to the view and ultimately redraws the user interface for the user. So we are currently on a background thread inside of this URL session. So thankfully for us, Swift automatically manages the transition of going to the main thread onto a background thread. And this data task guy happens on a background thread automatically because you don't want to involve blocking your main user interface while an API call happens. You just want it to go get the data, and whenever it's done, then you supply or you update the data so that the user interface can get updated. And you want that to happen on the main thread, but only when you're done doing the process that you need to, right? In this case, fetching data from our API. So back to our diagram, guys. If you try to update your user interface directly from the background thread, it's going to give you an error, right? So this is illustrating that we can have multiple background threads, and if we try to update the UI from that background thread, it gives us an error. So basically what we need to do is go from the background thread back over to the main thread, and the main thread can then update the user interface. So there is some transitioning that happens between threads, and we just need to make sure that we do that stuff correctly so that we don't run into any sort of problems in our application that could potentially lead to crashes or poor user experiences, right? So what I want us to do now, guys, is hop back into the code and add some code to our program to really showcase how this stuff works and give you guys a better understanding of that through use of an example. So let's go back. Into our coins view model, and I want us to go ahead and see if we can print out the thread that we're on throughout the process of this function. So when the function starts, let's go ahead and say print thread.current, and this returns the thread object representing the current thread of execution. So let's see the thread that we're on when we start this function. And then let's see what thread we enter into when we go into the completion handler. And then in this dispatch queue.main.async guy, let's go ahead and print the thread out again. So let's go ahead and run our code, guys. Oops, I made a capital P there. And let's see what these print statements give us back, and let's see how that relates to our diagram. So we see that the first time we get that print statement, we are on the NS main thread, right? And then we see that we go fetching price, and then we see did receive end of function, right? And then we enter back into our callback or our completion handler after we get our data back. And then, guys, we see that we're no longer on the main thread. We see that we're on just a regular NS thread. So this represents switching over to a background thread. So if you guys remember what I was talking about, Swift automatically handles that for us in this data task function. They automatically switch us over to a background thread when we are doing this data task, which is really nice. We don't have to do that thread management ourselves. And then the interesting part, guys, is that the third time we get this print statement, we notice that we're back on the main thread, right? So once we get to here, we go back onto the main thread so that we can ultimately update our UI. So that is exactly what we're seeing here in our diagram. The program starts out on the main thread, it goes to a background thread, and then when the background thread is completed with its processes, we get back onto the main thread and then update our UI. So I want us to add one more thing in the code, guys. Let's go ahead and add another fetch price. Litecoin. And let's go ahead and run our code again and see what happens. So we get some interesting stuff back here, guys. So let's unpack this and break this down. So we notice that the function gets called once, and we see fetching price, and we reach the end of the function, and we're on the main thread. So that represents the first time fetch price for Bitcoin is called. And then the second time, we notice that we're on the main thread, we're fetching price, and we reach the end of the function. That's when the fetch price for Litecoin gets called, right? And then we notice that when we're here, we are now on a background thread, and we get back the data for Bitcoin. And then we update the main thread once we go onto this dispatch queue.main guy. And then after that, we enter onto a different background thread to fetch the Litecoin data, and then enter back onto the main thread to ultimately update our user interface with the information that's coming from that particular thread. So this really showcases this the final state of this diagram, or the state of this diagram, where we have two background threads that are executing concurrently, right? One was thread 3, one was thread 7. One is in charge for fetching Bitcoin data, one is in charge for fetching Litecoin data. And we notice that we have to get back onto the main thread from each of these guys to update our user interface. We cannot do so directly from our background threads. So that just gives you guys a comprehensive and a visual breakdown of what exactly is going on with this threading stuff. And it's important to understand, guys, because you always want to make sure that you are being thread safe, and you're doing things on the correct threads when you are using networking within your application. And it doesn't have to be networking. It could be any sort of complex task, right? So like I said before, if you are executing some algorithm, right, like a ranking algorithm for like a social media feed or something that takes a lot of time to execute, you're going to want to do that on a background thread. So you want to keep the main thread as clean as possible, because you want your user interface to be as responsive as possible. So that's why this stuff is important here. It's important to understand this to make sure you're developing quality apps with quality user experiences. And that's going to wrap it up for this video on threads, guys. In the next one, we are going to get into error handling and how we can handle different responses that come back from our callback here to really get a full comprehensive experience and end-to-end functionality of what to do if things go wrong. So get excited for that. We'll see you there.